time. So this webinar is about Azure DevOps. So a DevOps solution that is given by Microsoft to enable your organization to move rapidly into Azure. But as we know, when we talk about Azure DevOps, we should be clear about what is cloud computing. Also, what exactly is this DevOps? We know that this is a buzzword. Sometimes we will get to know like DevOps is there, then DevSecOps is there, then NoOps is there, site reliability engineering is there. And a lot of buzzwords are there in the industry. Now there is another area like microservice design patterns, Docker, Kubernetes. A lot of terms are there. So my agenda here for the next 2 hours will be to introduce you to give a 1,000-foot overview for to you about what exactly is DevOps and what DevOps is not. Then once we go through all the principles of DevOps and automation tools that can be used with DevOps, we will jump into Azure DevOps. So that will be a nice idea to do in a 2-hour session, because directly starting with Azure DevOps may confuse you a little bit if you are not from the area of DevOps. So if you are already a DevOps engineer, it might be slightly a revision for you, but we are expecting participants who are also new to DevOps concepts, right? So we'll start with something called as source control. Then what is a build and release process? How we can automate these processes using continuous integration. So this is another buzzword like CI/CD. Everywhere you will see pipelines, continuous integration, continuous delivery. What exactly that means? Now we will talk a little bit about what is continuous delivery and what is the difference between continuous delivery and continuous deployment. To give you a head of digital transformation, we will directly jump into the latest technologies used in DevOps, which is microservice architecture using Docker and Kubernetes. We will talk a little bit about what exactly is this technologies means and how exactly it facilitates the time to market a product or to give a better solution, better feature for a customer without or I can say with confidence, without a downtime. Finally, we will go into Azure and we will see a lot of difficulties in implementing all these technologies for your enterprise. We will introduce a lot of cloud agnostic tools, but to handle those kind of tools, you need to have a great learning plan where you need to understand all these individual tools separately. You need to maintain them in different environments. You need to create machines, install these softwares, create master slave architectures. A lot of work has to be done to implement DevOps for your organization. Now there comes Azure DevOps. How exactly Azure simplifies this entire process. Within few clicks, you can implement the entire DevOps cycle for your organization. So we'll talk about why Azure DevOps is important, how it is possible, and what we can do with Azure DevOps. So there are my colleagues available here. If you have any doubts, questions, you can always go in a Q&A section and ask, and then they will be happy to help you out. So demystifying DevOps. What exactly is the term DevOps indicate? So this training is known as DevOps Essentials or DevOps 101. We call it in that way, where we will introduce you what exactly is the process of DevOps. Okay. So it is something related to software development lifecycle. We all know what exactly are the stages in software development lifecycle, right? So first stage will be requirement gathering or analysis of the requirement. We will go to the client, gather all the requirements. Now, based on that, we need to create an architecture. We will design the software. Then the developers has to start coding or implement the software. Then we have to test everything is working, starting from unit testing to integration testing to UAT. We have to do all the testing process. Finally, we have to deploy that particular software into production servers or server machines which serves the applications, right? And there comes the operation and maintenance, where we have to make sure that the software is running properly. We will see what all engineers are involved in this process. So what is our mission? We have to create a software and we have to deploy it into production servers so that the customer can now use the software. So first, we need to develop softwares and deploy that. So the customer, end of the day, when you deploy the software to the production, then only the customer or user can use it, right? Now the customer will give you feedback, your site is down, you have to operate the software, you have to operate the environment and make sure that the site is up and down at any point of time. So which all engineers are involved in this process in a traditional method? Definitely devs or developers are involved because they have to write the software, then only we can deploy the software. Now, we know that the developer writes the code in high-level format, like let it be a Java code, .NET code, Python code. It's high-level program. Taking an example of Java, if the developer write it in high-level Java program, we have to compile that code and package that code into an artifact. We call it as an artifact, or we can, as of now, we can call it as an executable, where the executable is a binary that can execute on production servers so that the site will be visible. So in case of Java, we can say a .var file or .jar file has to be created from the high-level program, which needs to be supplied to the customer. That only can execute. So we can simply understand it if you are new to this term called build. Let's say we have the source code of web browser Firefox. We cannot directly run that source code, right? So we have to get an exe file in case of Windows to install that program. That process is known as compiling of the code. In case of compilation languages, there are interpreted languages which like Python, PHP, which work in a different way. But let's talk about Java or .NET. We have to compile the code and package the code along with the dependencies so that it can run with all the dependencies. So the engineers who converts this high-level program into executable formats are known as build engineers, and that process is known as building the software. So for building the software, let's say it's a very heavy software, then you need big machines, which is installed with certain build tools. In case of Java, we can say Maven or Gradle or Ant or NuGet in case of .NET, right? So build engineer, so developer has to write the code and he has to give the code to the build engineer and wait for the result of building. I mean, yeah, build is successful, your artifact is ready to go to the next stage. Now comes the quality assurance team. They have to test the software. Yeah, build is successful, but if the software is working in the way that is expected to work. So QA team or testing team will come into picture there. Then, yeah, it's okay, your software is working or your module is working, but whether this module is working with other modules. So there comes integration testers. And finally, we have to give a demo to the customer so that some of their employees or their friends comes and test the softwares and tells us whether the software is up to the mark for their clients to use. So user acceptance testing is coming. And finally, that artifact or executable has to be given to operations. I can tell my story. When I started my job as a Linux administrator, I have seen this process happening in a very much manual method, right? So we were sending these packages manually from one team to other. And definitely, as of now in the industry also, we can see all these divisions are separate. Like developers are sitting under some team lead, build engineer is sitting under the build team. Then we have test team separate, operations. Definitely, it's a different set of administrators.